Um, Today we are going to talk about the analysis of variance. The analysis of variance is a continuation of hypothesis testing for the equality of population mean, the population average. Now, we did the hypothesis test for one variable and one population. And so now the next step is that we did hypothesis testing to test the equality of two population means on the same variable. For example, we did a hypothesis test to compare, say, the average age of females to the average age of males, the average income of union workers to the average income of non-union workers. So we looked at two subpopulations looking at the same variable. Now, we're going to move to the next stage, which is to test for the equality of the average or the mean, the equality of means for three or more subpopulations, like three or more groups. So that is what we're going to be working on today. So I'm going to share the screen. Okay, so are you seeing the screen? Hello?
Hey, Professor, I just have a quick question. This session is being recorded, right?
Yes.
Oh, I'm just asking because my phone, I'm on my phone right now and it's dying. So if it dies, it might disconnect. So just letting you know beforehand.
Okay, all right. You're on your phone and if it's dying, I will just continue the lecture. And then I'm going to post it online. All right.
All right. I just wanted to make that clear. I don't want you to think that I just left.
Okay. All right. Fine and good. So our objective is to now go from testing hypotheses for one population, and then we test hypotheses for two subpopulations on the same variable, like comparing males to females, comparing union workers to non-union workers, comparing the night shift to the day shift, comparing one location to another, Pennsylvania to New York. So comparing Bed-Stuy in Brooklyn to Wicksville, so on and so on. So now the next stage in hypothesis testing for the equality of means is to look at three or more subpopulations. And we call that analysis of variance. So in this analysis of variance, analysis of variance goes beyond just testing the equality of means. You also do analysis of variance to test the equality of variances. But for this class, we will just focus on analysis of variance to test the population means, equality of population means. Now, beyond just testing for the equality of population means, what we're doing for this class, again, is called one-way analysis of variance. So this is, again, another limitation of what we're doing, because going into, say, two-way analysis of variance and then two-way analysis with blocking variable, these are all different things that we can do. But we're going to go just the very simple analysis of variance, which is analysis of variance, a one-way analysis of variance, or it's called one-way Anova. Okay. One-way Anova. All right. So that's what we're going to do for this session. And in order to test the analysis, the hypothesis, test hypothesis for, say, one population or for two populations, we use the Z table. Sometimes we use the T if we have a small sample size. Now, to test for the equality of population means for three or more subpopulations, we will use what we call the F distribution. F is in Frank. We use that to test the two population variances are equal, but we also use it to test that three or more population means are equal. Now, once you ask yourself the question, are the population means for three or more subpopulations, are they equal? If you reach your conclusion by rejecting or not rejecting the null hypothesis, you also want to look at pairs of populations. For example, suppose you tested for the equality of means, say between Bed-Stuy, Crown Heights, East New York, and say Wicksville in Brooklyn. So you're looking at 4 populations there. Now, once you're done testing your hypothesis, whether all the means are equal, the next thing that you want to test is to compare pairs of them. So you compare Crown Heights to Bed-Stuy, then you compare Crown Heights to Wicksville, then you compare Crown Heights to East New York. Okay. Now, here we made clear that our objective is to test whether all the population means are equal. Okay. Like here you have mu1 to mu2 to mu3 to mu4 to mu k, where k represents the number of subgroups. You don't know, so we're using a generalized symbol here for k to mean the if you have 10 subgroups, then k will be 10. Okay. Now the alternate hypothesis is that at least there is one pair, I and j, where I and j could be anything. Could be you're comparing 1 to 2, could be 1 to 3, could be 1 to 4, or you're comparing 2 to 3 or 2 to 4, or you're comparing 3 to 4. At least there's two subpopulations that are not equal. Okay, like I said, we do this using the F distribution, and the F distribution has 2 different degrees of freedom. And we're going to 2 different degrees of freedom. So again, this is a sample of the F table. You have the numerator degrees of freedom, which is k minus 1, k being the number of subgroups. And so if there are 4 subgroups, the first degree of freedom will be 4 minus 1, which is 3. If there are 7 subgroups, then the first degree of freedom will be 7 minus 1, which is 6. Now, suppose that when you add all the subgroups, say there are 10 in group 1, 15 in group 2, and 20 in group 3. So you're looking at 10 plus 15 plus 20, which is 45. So the second degree of freedom will be 45 minus the number of groups, which is 45 minus 4. And so if you look at the F table, you will see here that the numerator degrees of freedom, then there is the denominator degrees of freedom. And so if you have 18 denominator degrees of freedom, then you're going to be looking, and there are 3 groups, or actually 4 groups, then the denominator degrees of freedom will be k minus 1, which is 3 degrees of freedom. And then you're going to have 18 degrees of freedom here. So the critical value of the F distribution that you're going to use for your test will be 5.09, 18 degrees of freedom and 3 degrees of freedom. Okay, we're going to look at an example as we go, a practical example. Okay. So as we said earlier, the null hypothesis will be that mu1 is equal to mu2 is equal to mu3 is equal to mu4 until all the subgroups are exhausted. Now, there's a mathematical process for calculating F, but I'm going to simplify that process. And maybe next time, if somebody has a question, then we can go through a complete problem. Okay, but as you can see in this case, we have 4 different groups. Okay, there are 4 different groups here, and so the degrees of freedom will be 4 minus 1 for the numerator degrees of freedom. So 4 minus 1 will be 1, 2, 3, 4. Minus 1 will be 3 degrees of freedom in the numerator. Now, how many degrees of freedom in the denominator? Here, Northern Group has 4. WTA has 5, that's 9. And then this other group has 7, so that's 15. And then you have 6 here, that's 21. So 21 minus 3 will give you 18 degrees of freedom for the denominator. Okay. So now let's go to the practical problem. Okay. Now in a test of hypothesis, you set a level of significance. When you set a level of significance, then you choose from the F table. In this case, you are looking at 0.01 level of significance. And so you go here, that is why you have the critical F statistic will be 3 degrees of freedom and 18 degrees of freedom. And so that would be 5.09. All right, so let's see if we can look at a practical problem. Okay. The practical problem we're going to be looking at here is a problem about houses in a neighborhood. So I'm going to look at problems of houses in a neighborhood. Now, in this neighborhood, there are 3 styles of houses. There are 3 styles of houses. The tri-level houses, that is with 3 stories. Then there are 2-story houses, and then there's ranch houses. A ranch is 1 story. So the question that arises is very simple. Are the average ages of houses the same regardless of style? So in this neighborhood, are the average ages of houses, were these houses built about the same time? Okay, regardless of style, where R is ranch, TS is 2-story, and TL is tri-level. So the null hypothesis will be that mu R is equal to mu TS is equal to mu TL. Okay. The alternate hypothesis will be at least there is 1 pair of groups with different average ages of houses. So, for example, mu R might not be equal to mu TS, or mu R might not be equal to mu TL. Okay, so that is the alternate hypothesis. Now, using summary statistics, which I will provide for all the problems you're going to do here, using summary statistics, you calculate what you call mean square errors, okay? Mean square errors. And we call, so you calculate the mean square error for treatment differences. Now, what are the treatments? The treatments are the different groups. For example, there are 3 different treatments in our example here. The tri-level, the ranch, and the 2-story buildings. Those are the treatments, okay? And then there is the SSE, the mean square error, and then there's the total error, okay? And so the F distribution is calculated as the mean square error, the average square residuals, which is called MST divided by MSE, okay? All right, so here, for example, the SSE, the error, the residual errors, the mean square residual error is summation x minus xc, which is actually for each group. Okay? We will get to that kind of detailed calculation next time. All right. So now, for purposes of this class, we're going to print out an SPSS, output. So you're going to receive, for example, information on the mean square, the sum of squared errors for the treatment, which is for the groups, and then the sum of squared errors between the groups. And so the degrees of freedom, since we have three different groups, the degrees of freedom will be 3 minus 1, which is 2 degrees of freedom. And the mean square error will be the sum of squared errors divided by 2. Okay? And then you have, which is 289 divided by 2, which is 144. And the sum of squared errors will be 2029 divided by 105, which is 19.3. And so now the F distribution, or the calculated F will be 7.49. Okay, the 7.49, which is 144 divided by 19.3. Okay. Now, so how do you now use that to do a test of hypothesis? Okay, how do you now use that to do a test of hypothesis? All right. Now, how you use that to do a test of hypothesis, and we're going to now go and solve an actual problem. How do we use that to do a test of hypothesis? We're going to now compare this F distribution to a critical F. So how do we do that? Okay. I'm going to stop this share. I'm going to see if I need to stop the share. So this is 5.09. Okay, so you don't have enough here. So just give me 1 minute. Let me see if we have a table. Okay, we seem to have a table here, and I'm going to pull up that table for a minute. So I'm going to stop share for this, and I'm going to share something else. Okay, so now I have an F distribution for a 0.01 level of significance. Now, the F distribution we're going to use is going to be F distribution for 2 degrees of freedom and for 105 degrees of freedom. This table does not have 105, so we're going to use 120, which is the closest that we have. So let us see if, okay. All right. So as you can see here, if you look at 2 degrees of freedom and go down to 120, so the critical degrees of freedom we're going to use is 4.79. Okay, take note of this. We're going to use a critical F, or an F star. We have been using stars, so we're going to use a critical F statistics. Our F star will be 4.79. All right. So we're going to stop sharing this, and then go back to our PowerPoint slide. So we're going to okay. selecting the critical F value. Okay, the F value here will be F4 0.01, and we have K minus 1 and minus K. All right, which in this case will be F at 0.01 for 1% level of significance, and K minus 1, since we have 3 groups, with 3 minus 1 for n minus K degrees of freedom. Altogether, we had 100 and let's see, okay, altogether we have 108 observations actually. So 108 minus 3 will be 108 minus 3. And so F will be F 4.01 and 2 degrees of freedom to 105 degrees of freedom. All right. I'm going to make this very clear so that we don't confuse what we mean here. So these are going to be subscripts. Okay. So going to be subscripts. All right. So this will be the and we said we selected 4.79. So our critical F value will be 4.79. So when we looked at this table, we find out that the calculated F is 7.491. And so we have our calculated F from the table. From the SPSS table is 7.49. And very simply, we apply the decision rule as usual. It is if F, the calculated F, is greater than or equal to F star, we reject the null hypothesis. Okay. All right. So here we reject the null hypothesis if F is greater than F star. So what is our decision here? What's our decision? We see that if F, and our F, the calculated F is 7.49, is greater than or equal to 4.79. Okay. Oh Lord, what did I do? Okay. Then we reject the null hypothesis. Reject the null hypothesis. Okay. So here we are rejecting the null hypothesis that all the means are equal. So there is definitely one pair, one group of one pair of groups where the average age is not equal. So we reject that null hypothesis. And once we reject the null hypothesis, what next? So let's see what we do next. Okay. So in this case, we reject the null hypothesis. Okay. The null hypothesis is that all the means are equal, all the average ages are equal. So here we are, 7.49, and so we're rejecting the null hypothesis that all the average ages are equal. So we go to the next step. Once we reject the null hypothesis, now our job is to ask which two groups are not equal, which two groups of averages are not equal. So now, so we have to now compare the three styles of houses in the neighborhood, all right? So we look at, again, the SPSS table, which is what I want everybody to be able to do in this class. We compare the tri-level to the two-story and to the ranch, okay? So we see, for example, that if you look at the confidence intervals of the comparisons, and we use the confidence intervals of the comparisons to decide which two groups are equal and which two groups are not equal. So if you look here, you can see that when you compare the tri-level to the two-story, you will see that the confidence interval of their difference is all negative. Okay, it's all negative, and therefore the average ages of tri-level and two-story buildings are not equal. There's a significant difference in them because the confidence interval of their difference is all negative. But when you compare the tri-level to the range, you see that the confidence interval of their differences goes from negative to positive. That means their average ages are equal. That is, you are not able to reject the null hypothesis of no difference. Now, what does that mean? Let's think about a practical business example. It might mean that when this neighborhood was being developed, what it means is that they began by developing tri-level houses with ranch houses. And so the two-story houses may have come at a different time. So let's look at the two-story compared to the tri-level, okay? The two-story compared to the tri-level, as we can see, the confidence intervals here are positive, okay? They go from positive to positive. That means that there is a significant difference in the average ages of houses. You see it in the original comparison. When you compare the two-story to the ranch, okay, you also see that there is a significant difference between the two-story and the ranch because the confidence intervals are positive. Okay, they are positive on both sides, the lower bound and the upper side. But if they go from negative to positive or from positive to negative, then you are not able to reject the null hypothesis of equality in those two groups. So this is basically what Anova is about. This is basically what the analysis of variance is about. So this is what I would like the class to learn in analysis of variance so that next time we can move on to regression analysis. I need for you to complete your assignments. I'm going to move the, what do you call it? The deadline for the assignment, I'm going to move a few more days so that everybody will have an opportunity to complete the assignment. If you have already done any past assignments, including this one, and you feel like you want to revise your assignment, please let me know, okay? I believe I provided the summary statistics so that everybody is able to do the assignment. Let me check. Let me check. Just give me a minute. Okay, so what I observed that I set up the assignment and expected you all to use SPSS to do it by yourselves. No, I'm going to go and modify the assignment and run the SPSS and then provide you with the summary statistics. And I want to need tonight, provide everybody with the summary statistics so that you can all go and do the assignments based on the summary statistics. And I'm going to also make that modification from now on, so that either you can use Excel or you can use you will use summary statistics from SPSS, which I will provide for you because I was not able to get the college to give you remote access to the SPSS. So this is the way I'm going to do it until I can get the college to provide the remote access. Okay, so do you have any questions? All right. All right. So I'm going to leave it here. If you have any questions, give me a call, and then I'll take it from there.